students, good morning. Now today we are going to discuss about the mechanism of ascent of sap. Mechanism of ascent of sap. Okay. So in the mechanism of ascent of sap, we are going to discuss a theory, and that theory is known as the transpiration pool theory. It is known as the transpiration pool theory, or this theory is also known as the cohesion tension theory. It is also known as cohesion tension theory. Okay. This theory was proposed by the Irish botanist. The Irish botanist Henry H. Dixon. Henry H. Dixon and the physicist John Jolly in 1894. Okay. So this theory was proposed by Irish botanist Henry H. Dixon and physicist the John Jolly in 1894. So this theory is also known as the Dixon and the Jolly's theory. Okay, Dixon and Jolly's theory of cohesion, or the cohesion tension theory, Okay. So this theory is widely accepted and it is fully supported by the evidences. Okay, and that evidences were the experimental evidences which proved that the ascent of sap takes place by means of this mechanism. So this mechanism, which is the transpiration pool, or by the cohesion tension. So many of the scientists, they supported this theory and they accepted that and confirmed that the ascent of sap occurs through the mechanism of transpiration pool. Okay. So this theory, it has some important features. Okay. It has some important features. So these important features of this theory, Okay. So the important features, the first of all, the water molecules, they have the strong attraction. The water molecules, they have the strong attraction between them. They have the strong attraction between them. Okay. The first point, water molecule, they have strong attraction between them. Okay. And that strong mutual force of attraction, it is known as the cohesive force. Do we know that the water molecule, it is bipolar in nature? The one end is the positive and another end is the negative one. And therefore, these water molecules, they have the strong attraction between them. And due to that strong attraction, this force is known as the cohesive force. So the first feature, the water molecules, they have the strong cohesive force. The second feature of this theory, this force, that is this cohesive force, it is near about 350 atm atmosphere. Okay, this cohesive force, it is near about 350 atmosphere, and 350 atmosphere means it is more than enough. It is more than enough to carry the water up to 200 meters. Okay, up to 200 meters. And therefore It is the most strong point of this. Then the third point, due to this strong cohesive force, the water molecules or water column, it remains unbreakable. The water column in xylem, it remains it remains it remains unbreakable. It remains unbreakable even though it is subject to the many disturbances. That means, first of all, this water molecule, they have the strong attraction between them, and that force is known as the cohesive force. This cohesive force, it is the strong force. It creates near about 350 atmospheric pressure, which is more than enough to carry the water up to 200 meters or more than 200 meters. Like the question was, it is how it is possible to carry the water in the highest or tallest tree like this sequoia or the eucalyptus trees. Okay, म्हणजे sequoia, redwood किंवा eucalyptus, निलगिरी, हे इतके उंच प्लांट मध्ये इतक्या वरपर्यंत पाणी जे वाहून जातं, तर ते कोणता असा फोर्स आहे ज्याच्यामुळे इतक्या वरपर्यंत पाणी वाहून नेलं जाऊ शकतो. तर त्यातला पहिला जो पॉइंट आहे हा जो कोहेसिव्ह फोर्स किती असतो 350 ATM, आणि हा 200 मीटरच्या वरपर्यंत पाणी वाहून नेण्यासाठी सफिशियंट असतो. And the next point, water column in xylem, it remains unbreakable due to this cohesive force. That means water molecule, it has a strong attraction. Due to that, the water column in the xylem, it remains as an unbreakable column. Okay, it remains as an unbreakable column, and therefore it can be easily carried upward. Okay, easily carried upward. As like the cohesive force, there is the one more force, it works in the xylem and in between the water, and that is the strong force of adhesion. That is the strong force of the adhesion. The adhesion force means what? It is the attraction between. It is a strong attraction between the xylem wall and water molecules. Xylem wall and water molecules. Okay, water molecules. So, this strong adhesive force, as like the cohesive force, the adhesive force also plays most important role in conduction of the water. Okay, and due to this adhesive force, the water, it remains or held in the capillaries of the xylem, or we can say that in the lumen of the xylem. Lumen means the xylem च्या ज्या cavities आहेत. Okay, त्या cavities मध्ये जे water unbreakable column च्या स्वरूपामध्ये राहतं, आणि त्या ठिकाणी पाणी धरून ठेवलं जातं त्या वॉल मध्ये, xylem च्या वॉल मध्ये. So it is due to the adhesive force. Okay, so due to the cohesion, water, it remains as a continuous water column. Okay, or it is remain as a intact and continuous from root tip to the shoot tip, and it is up to the mesophyll of the cell. Okay, there is one more phenomenon takes place, and that is the continuous and heavy loss of water. There is the continuous and the heavy loss of water. From where? From the surface of the leaf, and it is during the transpiration. Okay, in the form of water vapors during transpiration. Okay, during the transpiration, the water loss in the form of water vapors. Okay, so there is a continuous heavy loss of water during the transpiration, and due to that, it creates a suction or pulling force. Okay, due to that, Due to that, it creates the suction or pulling force. Suction or pulling force. Pulling force किंवा suction force म्हणजे काय, ओढून धरणारा force. Okay, so that is the suction or pulling force. Okay, and that force, that suction force or the pulling force, it is known as the transpiration pull. It is known as the transpiration pull. It is known as transpiration pull. Okay, so the value of this transpiration pull is also very high. Okay, its value is very high. That means it also produces the sufficient atmospheric pressure, or it has very high atmospheric pressure, which is enough to carry the water in the tallest trees. Okay, so it was observed that the transpiration pull or the tension created in the leaf, okay, this transpiration pull or this tension or transpiration pull, this tension or transpiration pull, it is created in leaf, okay, due to the transpiration, and this tension, it is transmitted through the continuous water column up to the root tip. Okay, from leaf it transmitted continuously through the water column up to the root. Okay, that means this tension or transpiration pool, आता हा टेन्शन किंवा ट्रान्सपिरेशन पूल कशामुळे क्रिएट झाला, ते कंटिन्युअस वॉटर लॉस ट्रान्सपिरेशन मध्ये होतो, बरोबर. त्याच्यामुळे जे टेन्शन किंवा ट्रान्सपिरेशन पूल किंवा ओढण्याचा जो फोर्स हा निर्माण झालेला आहे, तर या ठिकाणी हा कुठे निर्माण झाला, लीफ मध्ये, कारण ट्रान्सपिरेशन कुठून घडलं, लीफ मधून. आणि ते जे टेन्शन आहे, तर या ठिकाणी हे वॉटर कॉलम जो आहे झायलम मधला, तो थ्रू दॅट झायलम of the stem, leaf and the stem, it is transmitted to the root tip. म्हणजे रूटच्या टिप पर्यंत त्या ठिकाणी ते टेन्शन जे आहे तर ते ट्रान्सफर झाले. ओके, आता या ठिकाणी हा जो फोर्स आहे, द फोर्स ऑफ ट्रान्सपिरेशन पूल, तर हा काय करतो, इट अपलिफ्ट्स द वॉटर. इट अपलिफ्ट्स म्हणजे काय, की वर त्या ठिकाणी उचलून घेतो किंवा वर त्या ठिकाणी ओढून घेतो. तर या ठिकाणी it uplifts the water and mineral. It uplifts water and mineral. Okay, water and mineral from root to shoot. Okay, shoot means त्या ठिकाणी स्टेम पण आलं, लीफ पण आलं, फ्लावर, फ्रूट सगळंच त्या ठिकाणी येतं शूट म्हणल्यावर. आणि स्टेम म्हणल्यानंतर फक्त स्टेम येतं, शूट म्हणल्यानंतर पूर्ण वरची सिस्टीम येते. तर या ठिकाणी शूट, रूट टू शूट. ओके, तर या ठिकाणी अशा पद्धतीने ते ट्रान्सपिरेशन मुळे जो क्रिएट झालेला पूल आहे, इट अपलिफ्ट्स द वॉटर अँड मिनरल फ्रॉम रूट टू शूट. इट इज कंटिन्युअसली at any height of the plant. Okay, so the water which is under the xylem, or the water which is present in the xylem tissue, it is under the tension, and that tension it is due to the transpiration pool. And this transpiration pool, the force created due to the transpiration pool is very high, means it is near about 20 to 200 atmosphere. Okay, it is near about 20 to 200 atmosphere. That means it has ability to conduct the water or to uplift the water even up to the tallest tree. Okay, म्हणजे या ठिकाणी जे सगळ्यात टॉलेस्ट ट्री आहे त्याच्यापर्यंत, त्याच्या टोकापर्यंत सुद्धा पाणी कंडक्ट करण्यासाठीच लागणारा जो फोर्स आहे, हा या ठिकाणी इथे सफिशियंट आहे. त्याच्यामुळे इझिली वॉटर जे आहे तर ते वरच्या बाजूला पूल केलं जातं. ही जी theory आहे, this theory is mainly based on the transpiration pool and the cohesion and the transmission of the tension. Okay, म्हणजे या ठिकाणी तीन गोष्टी या ठिकाणी महत्त्वाच्या आहेत. The first काय, the transpiration pool. First काय, the transpiration pool. Second काय, the cohesion. Second काय, cohesion. And third thing, that is the transmission of tension. Transmission of tension. ओके, ट्रान्समिशन ऑफ टेन्शन. आणि या ठिकाणी मग यालाच आपण काय म्हणतो कंबाइनली, तर या ठिकाणी दॅट इज द ट्रान्सपिरेशन पूल कोहेजन टेन्शन थेरी. या सगळ्यांची मिळून या ठिकाणी काय बनते, ट्रान्सपिरेशन पूल कोहेजन टेन्शन थेरी. कोहेजन टेन्शन थेरी. ओके, तर या ठिकाणी ही थेरी जी आहे, तर या ठिकाणी देयर आर सम एव्हिडन्सेस टू दिस थेरी. ओके, तर या ठिकाणी कोणते कोणते एव्हिडन्सेस आहेत या ठिकाणी दिलेले पहा. तर या ठिकाणी एव्हिडन्सेस म्हणजे प्रूफ जे दिलेले आहेत. तर या ठिकाणी हे जे एव्हिडन्सेस आहेत, तर या ठिकाणी ह्या थेरीच्या सपोर्ट मध्ये जे दिलेले एव्हिडन्सेस किंवा प्रूफ्स आहेत, तर या ठिकाणी याच्यातला पहिला जो प्रूफ आहे, तर ते म्हणजे ऑस्मॅटिक प्रेशर ऑफ मेसोफिल सेल. ऑस्मॅटिक प्रेशर ऑफ मेसोफिल सेल. आता या ठिकाणी मेसोफिल सेल ऑस्मॅटिक प्रेशर म्हणजे काय, आपण याच्या पूर्वी पाहिले. या ठिकाणी जेव्हा वेन टू सेल्स किंवा या ठिकाणी वेन टू सोल्युशन्स ऑफ डिफरंट कॉन्सन्ट्रेशन सेपरेटेड बाय अ सेमी परमिएबल मेम्ब्रेन, the water move from low concentrated solution to high concentrated solution, and the pressure created in the solution, that is known as the osmotic pressure. ओके, हे आपण पाहिलं होतं. आता इथे जे आहे ते वॉटर लॉस होतो आपल्याला माहिती आहे, आणि वॉटर लॉस झाल्यामुळे त्या ठिकाणी पाण्याची त्या ठिकाणी कमी होऊन जे ऑस्मॅटिक प्रेशर त्या ठिकाणी क्रिएट होतं. तर या ठिकाणी हे कुठे पर्टिक्युलरली लॉस ऑफ वॉटर कुठे होतो, मेसोफिल सेल. मेसोफिल सेल म्हणजे कुठल्या, तर या ठिकाणी जर आपण या ठिकाणी लिप्स असं स्ट्रक्चर काढलं, तर या ठिकाणी हे बाहेरचं त्या ठिकाणी अपर इपिडर्मिस, आणि अपर इपिडर्मिसच्या खाली या ठिकाणी हे पॅलिसेड टिश्यू, आणि हे पॅलिसेड टिश्यूच्या खाली या ठिकाणी हे असे स्पॉन्जी टिश्यू. ओके, तर डायकॉट मध्ये जर पाहिलं तर आपण असं स्ट्रक्चर आपल्याला त्या ठिकाणी दिसतं. आणि या ठिकाणी पॅलिसेड याच्यामध्ये हे क्लोरोफिल्स, म्हणून या ठिकाणी हे ग्रेन. ठीक आहे, तर या ठिकाणी मग हा जो टिश्यू आहे हा पॅलिसेड टिश्यू. तर या पॅलिसेड टिश्यू मधून आणि हे स्पॉन्जी टिश्यू म्हणजे हा जो आहे याला आपण मेसोफिल असं म्हणतो. ठीक आहे, मेसोफिल. तर या ठिकाणी हे मेसोफिल सेल जे, तर इथे जो स्टोमॅटो असतो याच्यामध्ये, तर हे स्टोमॅटो मधून कंटिन्युअस त्या ठिकाणी वॉटर वेपर्स जे ते लॉस होतात. ठीक आहे, आणि त्याच्यामुळे जे या ठिकाणी प्रेशर क्रिएट होतं, तर या ठिकाणी मग हे जे प्रेशर आहे तर त्या ठिकाणी ऑस्मॅटिक प्रेशर. तर या ठिकाणी दिस ऑस्मॅटिक प्रेशर ऑफ दिस मेसोफिल सेल, इट इज मोर दॅन 20 ॲटमॉस्फिअर. ओके, 20 ॲटमॉस्फिअर पेक्षा त्या ठिकाणी जास्त असतं. आणि या ठिकाणी मग या ठिकाणी इट इज इंडिकेटेड दॅट this 20 atmospheric pressure is sufficient to carry the water up to 200 meters tall tree. Okay, it is more than enough. This 20 atmosphere, it is enough to carry water up to 200 meter tall trees. Okay, it is the first evidence. The second evidence that this process is purely physical. Okay, so there is no expenditure of energy. And even though there is expenditure, it is very negligible. Okay, it is very negligible. Then the third evidence, the tensile strength. The tensile strength of xylem sap. Xylem sap means the water which is present in the xylem cavity. So xylem sap. Okay, so this tensile strength of the xylem sap is near about 25 to 300 atm atmosphere. Okay, so So what is meant by the tensile strength? The tensile strength means it is the ability of the material to resist the tearing. Okay, म्हणजे एखादं मटेरियल जेव्हा आपण असं ओढतो किंवा त्याच्यात फोर्स लावतो तर त्या ठिकाणी ते फाटत नाही लवकर, तर त्याची जी ताकद असते न फाटण्याची, so that is the tensile strength. Okay, so it is the ability of material to resist the tearing, so that is known as the tensile strength. So tensile strength of the xylem sap, it is near about 25 to 300 atmosphere, and it is enough to avoid the breaking of water column. Okay, it is enough to avoid the breaking of water column. Breaking of water column. Okay, so due to that there is no breaking of water column. Due to this high tensile strength, no breaking of water column, and water it is move as a continuous water column. So it is the third evidence. Then the fourth evidence, it is the most important evidence, and it was the porous pot experiment. Okay, porous pot experiment, and that porous pot experiment, it confirms that the ascent of sap takes place through the transpiration pool. So what was that experiment? So I will draw here figure here. Okay, so there is a pot. Okay, and that pot is a porous pot. The porous pot means there are the holes which are present on this pot, which is made by the metal. Okay, and this pot, it arises on a glass column. Okay, or a glass tube. Okay, and this glass tube, it is placed or inserted in a glass disc which is filled with the mercury. Okay, it is filled with the mercury. It is the mercury, and over that mercury there is a water. Okay, here water. Okay, so according to this experiment, okay, this porous pot, it is allowed to evaporate. Okay, due to the porosity of this or the porous nature of this pot, it shows the evaporation through that porous pot. Due to that evaporation, the if the glass pot, or it is in the glass vessel, there is a mercury and the water, so it shows there is the raising of the continuous water column in this glass tube, and it was followed by the mercury. Okay, so this rise in column, it is due to the evaporation of water, and this rise in water, it is the continuous column. Okay, continuous column of water and this mercury here. So this water, as it lost in the form of vapor through this porous pot. Okay, through this porous pot, as the water loss takes place, this it shows the rise in water column as well as the mercury column. So the evidence is that the similar phenomenon, it may take place when we place, okay, when we place a twig in similar glass cylinder. Okay, so it is the mercury is the water. Okay, so the twig is placed here. So this vessel, it is filled with mercury and water because a twig is placed in this glass cylinder. Okay, and through that twig, okay, the transpiration takes place. And as the transpiration takes place, it shows the rise in column of the water and mercury. Okay, similar. So it is the evidence, it is the most important evidence that the similar phenomenon, that is the phenomenon which is shown in the porous pot experiment, the similar phenomenon shown here. Okay, so when this twig is placed uh, in a glass cylinder, okay, through that cut end the water is absorbed, okay, and there is a loss of water, and due to that this column it rises in that means the mercury is also uplifted here. Okay, it's shown that as the mercury rises, that means it creates the transpiration pool. Okay, so it is also the, it is known as the porous pot experiment. It is known as the porous pot experiment. It is known as porous pot experiment. So this porous pot experiment, it is also the most important evidence which shows that the transpiration pool is the important phenomenon by means of which the ascent of sap takes place. Okay. This theory also have, or this theory also, they have the few objections. Okay, few objections to this theory. Objections to this theory. Objection to this transpiration pool theory. Okay, so generally the first objection is that due to the variation in temperature during the day and night time, the large diameter of vessel, there may be the fair chances of the entry of water bubble in the column. Okay, so there is a difference in temperature. Okay, the difference in temperature between day and night. Okay, between day and night. And due to that, what happened? There may be the chances of entry of air bubbles. There may be the chances of entry of air bubbles in the xylem vessels. Okay, xylem vessels. So it is the most strong objection to this theory. Okay, so this objection is what? There is a difference in temperature during the day and night. So there may be the chances of entry of air bubbles in the xylem vessel. So according to the some workers, they stated that when there is a creation of the air bubble, the water column may become discontinuous. Okay, and due to this, it may show the disturbance in the water conduction. Okay, जसं आपण पाहतो की या ठिकाणी आपण मोटर चालू केली, जर मोटरने एअर बबल धरला तर पाणी त्या ठिकाणी ओढले जात नाही. The similar type of objection is this. Okay, but some scientists, okay, the Milburn and Johnson, the scientists Milburn and Johnson, they supported that, or they proposed that in 1966, they proposed that even though this problem is created due to the temperature difference. What problem? The creation of the air bubble in xylem vessel. Even though that problem is created, but as there is a decrease in temperature during the night time, this air bubble get dissolved. Okay, म्हणजे या ठिकाणी जर दिवसा टेम्परेचर वाढल्यामुळे एअर बबल आला, तर त्या ठिकाणी नाईट मध्ये टेम्परेचर कमी झालं तर काय होतं? सो दिस गॅस इट इज नोन ॲज द कॅव्हिटेशन. या ठिकाणी हे एअर बबल तयार होण्याच्या क्रियेला त्यांनी काय म्हटलेलं आहे? कॅव्हिटेशन. So even though there is a cavitation or there is a creation of the gases in the air column or water column, then also as the temperature decreases during the night time, these gases it get dissolved. Okay, so this air bubble it gets dissolved. So air bubbles get dissolved. Okay, so the problem automatically gets solved. And the answer during the daytime. So what about the daytime? During the daytime, even though the some xylem vessels they have the large vessels, large diameter vessels, and there is a air bubbles may created in that large xylem vessels, then also there are the number of xylem vessels surrounding to it. So even though one or two xylem vessels they may show the blockage, then also it do not alter the transpiration. Okay, or it do not disturb the transpiration. So transpiration is the continuous because there is a strong cohesive adhesive forces and the strong suction or the strong tension, cohesion tension is created, and that continuously the xylem vessels they are under the tension, and due to that tension and the transpiration pool, continuous transpiration pool, the water is continuous is move upward or uplifted as a continuous column. Even though the some vessels they may show the formation of the air bubble, so the surrounding vessels they show the continuous movement of the water, and therefore it makes no difference. Okay, and during the night time that bubbles which are created in the large vessels they automatically they get dissolved. So problem automatically get solved. Okay, so this objection also get rejected, and therefore this transpiration pool theory, this transpiration pool or cohesion tension theory, cohesion tension theory or the Dixon and Joly's cohesion tension theory, cohesion tension theory is accepted worldwide, is accepted worldwide. Okay, so I hope you got the points. Okay, so we will remind once again the transpiration pool or cohesion tension theory. It was proposed by the Dixon and Joly. So it is known as the Dixon and Joly's cohesion tension theory or transpiration pool theory. It is a worldwide accepted theory, and it was proposed in 18 and 94. So this theory it has and it is supported by the many scientists or many workers. This theory has some important features. There is the water molecules, they have a strong cohesive force. Then it creates the 350 atmospheric cohesive force. It is enough to carry the water up to 200 meters. There is similarly the adhesive force also present in water molecule and the xylem. So this cohesive adhesive force, similarly there is a continuous loss of water in the transpiration through the mesophyll cells of the leaf. So this mesophyll cells it creates the high osmotic pressure, and due to that high osmotic pressure it creates the tension, and then that tension it is transmitted from mesophyll cell or xylem of the mesophyll cell to the stem xylem to the root xylem, and therefore the xylem is continuously under the tension, and this tension it is responsible to pull the water from root tip to the shoot tip, and therefore it is known as a transpiration pool. This theory is supported by some experiments. The one of the experiment is the porous spot experiment. Then the another evidences osmotic pressure is of the mesophyll cell is more than 20 atmospheric pressure. Then tensile strength of the xylem sap is 25 to 300 atmospheric pressure. It is a simple physical phenomenon, so there is no expenditure of energy. So these evidences it strongly gives support to this theory. This theory it has one objection, and that objection was there may be the temperature difference in during day and night time, and due to that in the some large vessels of the xylem there may be the creation of the air bubbles, and this air bubbles sometimes it may block the water column, or it may break the water column, okay, or it may block the xylem vessel. But Melbourne and the scientists they supported that there is no such phenomenon or there is no such problem. So that means even though there is a creation of such bubbles, the surrounding vessels they show the continuous water conduction, as well as during the night time these bubbles get dissolved. So Milburn and Johnson they rejected this objection and supported this theory. So it is the most important and worldwide accepted theory. I hope you got the point. Thank you very much.